Returning to this course, today is the first class. We'll briefly introduce the upcoming teaching content, as well as discuss databases and what a database is, along with its management system, which is a highly relevant situation to consider. Then, as for the planned teaching content, today we will bring you the first lesson, which is about DB and DBMS, Database Management System. Then the following will introduce the next class, covering relational model and relational algebra. There will also be additional words at a later time, and subsequently it will serve as the storage for the database. When discussing storage, the primary emphasis is on the unconscious component, which is how the hard disk, SSD, HHD, stores data in a manner that is pertinent to the hard disk. Next is the lockref of the hash, how to establish a lockref in the DBESP, the hashy table method. Then include the lockrefs and queries of this B+ tree, as well as the processing of related query. And some additional information about the concurrency control mechanism employed in our distributed databases and its related content. Essentially, when you combine these materials, it's regarding the database management system DBMS and associated content. Of course, if everyone is interested, I may talk about this circle, but I think it doesn't really matter whether I talk about it or not, because I think if everyone wants to learn this database-related course, there will still be a lot of circles. There are a few advanced circle and some related query optimization. That is, how do I perform query optimization when I execute queries? I favor this side as I did compiler optimization at CMU, which is also relevant to the compiler optimization work I used to perform. Additionally, there is a recovery system which is used to recover the system in case of data crashes. How can I recover the system after a crash? Including some distributed OLAP databases, as well as some related content on distributed OLAP, etc. If interested, you can also send bullet comments, speak in group, or communicate with CC to leave more comments. If interested, I can give lectures on the 4 topics to everyone in the future, providing more interaction with us in the GitHub community. We are going to cover the courses on the left. Today's first class is about going to 101, which is a very introductory way to talk about some relevant definitions of databases and why we need to create a database management system. I have an operating system, I have a file system. Can I just write programs directly in files to operate? Why do I have to create a database? So if we define it from an academic perspective, what exactly is a database? What are the different approaches or techniques that can be used to create a database? And what is the distinction between it and the database management system we previously defined? When discussing databases, is it a database or a database management system? Today, from a basic and obvious perspective, I will provide you with a clear understanding of databases and database management systems after our study session, enabling you to grasp the key concepts and principles involved in these fundamental components of information storage and retrieval. When you go out and discuss databases with your friends, you can develop a very clear and intuitive comprehension of what a database is from a conceptual perspective. Okay, firstly, let's define the database. In this standard, in the 7th edition of the database system, it is defined as organizing the collection of interrelated data that models some aspect of the real world. I have already identified the concept that needs to be understood. This means that we need to create models of certain aspects of the real world, and these models are comprised of interrelated data and organized collections. They serve as a representation of the real world and provide valuable insights. It has a series of very clear definitions. First of all, we say it is the real world. That is, it is about the real world. Whether this real world is described by our reality or imagined by us, when we all play this Cyberpunk 2077, it also forms a similar world. But whether we are talking about the world described by our reality or the world imagined in this game, it is ultimately a real world, the real world. It is a significant, reasonable entirety formed by these actual worlds that possess true meaning and significance. Certain facets of them, these particular aspects, are not all entities within the confines of this tangible world that we inhabit in our everyday lives. All datasets, it's impossible for us to build a complete one for all entities and datasets in the real world. When, for instance, creating a database like a personnel or vehicle database, it must represent aspects of the real world accurately. Then, in this regard, if we extract the aspects of this data, then this data in the end, if it has interrelatedness, for instance, I am a student in the computer science department, and these aspects of data have generated inherent associations between them, which are significant for understanding the overall context and implications of the data in a comprehensive manner. And when these associations occur, they can be organized and aggregated in an organized manner, forming a collection, a set. So, okay, regardless of whether it is a data set or an organized collection, it still fulfills the definition of a database in accordance with the established criteria. We can define it as a database, regardless of whether it is a file in a real database management system, DBMS, or a CSV file that I wrote, no matter what the circumstances may be. Or say my one-by-one cell-related files, even if it's world, I wrote something. When it has these characteristics, we can define it as a database. But it must be said that this database is actually different from a database management system. Database management system is a series of standardized operations and definitions that I have made in order to manage organized data collections. So what I will talk about next is what this database management system is. So let's see, the database is still very important in this overall industry chain. This may be biased towards this kind of market and industry. Let me briefly explain to everyone. When we plan the IT-related industry chain, we actually divide it into 3 sectors: upstream, midstream, and downstream, each involving different manufacturers. In terms of upstream, it actually refers to specific hardware manufacturers, such as foreign ones like Cisco, and certain related ones that produce CPUs like NVIDIA and Intel, for example, in the technology industry. Hardware manufacturers like Huawei and ZTE in China. Relevant manufacturers. In terms of mid-range, it refers to vendors based on hardware foundations. What is technical software? We discussed the main components: operating systems, databases, and compilers. Undoubtedly, it could also be due to the fact that these specific courses, namely compiler principles, database systems, and operating systems, are widely recognized as the most demanding and formidable in our university, thus acquiring the reputation of being nightmares among students. They form this basic software vendors, including some possible corresponding communication middleware, like our message array middleware, some communication middleware, some message storage middleware, and some middleware for data cleansing. Then downstream, it means that everyone's application developer, for example, I am developing an APP, I am an application developer for an APP, and more are some enterprise services, which are what we have been talking about in recent years. SaaS, which means software as a service. These application developers may produce some enterprise ERP. Of course, the downstream is more powerful in terms of curling. If anyone is interested in exchanging ideas later, I think you can personally experience it by taking a look. Upstream, midstream, and downstream form an IT industry chain. System integrators, developers, and database vendors are basic software vendors in the chain. He's in the middle of the upstream and downstream of the industry. Upstream is connected to software vendors and source code licensing related vendors. So ultimately, he's actually referring to the end user, such as myself, a government entity. I can utilize my database software to store his pertinent data and subsequently perform the corresponding applications. Including some large financial, telecommunications, energy, military industries, etc. They are all end users. So I can also correspond to some system competitors. That is, he compares my software with other software, such as databases. Some databases, like kernels, are well known for continuous data storage, and it is a continuous database. But he may need to work with some relational databases, such as Oracle and so on. Then the application integrator will package these database software, including applications, together, and finally provide them to the service end customers. So in terms of this database vendor, it still holds a very important position in the middle of this industry chain. It functions as a hub connecting the upstream hardware to the downstream applications. As a result, the database vendors are unable to grow big, or if they do manage to grow big, they inevitably become very large in size. The space and capacity of this related market are very good for it. Next page. The next page is, oops, sorry. Another thing is, for instance, when we're building a database, like let's consider a simple example, like building a database for online music modeling and then using it to record singers and albums. This data needs to be stored, and it's straightforward. The first one is the singer's information, and the second one is the information about the albums released by the singer. Concerning the information of the singer, I can say that it's very simple. The main thing is the name. Currently, well, I'm using this example to help everyone understand the concept of this database and also to include some aspects of the database. I'll propose things like, can this work, can that work, to introduce why we need a database and why we need a database management system and so on. So we need to store singer information as well as information about the albums released by these singers. So the next step is to create a database. It could be a flat file like a CSV file, which is very simple. Here I have written it as a CSV file where each line represents a tuple and each attribute is separated by a comma. Then I will construct the artist file for the singer, which contains their name, debut time, and country. So there are 3 pieces of information: Fei Wong, Eason Chan, and Jay Chou. Another one is info about this album, which is also a name, the album's name, and info about the singer as well as the year of production. Such as this Fei Wong's I'm Willing or Only Love Strangers. This is 1997, 1999, and then it is associated with this data of 4 items such as Jay Chou's 2020, 2001, and so on. If I am curious to know which year Jay Chou released his first album, it actually has this record of debut time. How should I do it? I can write a very simple program in Python to read information from a file. In this file, I will read each line and check if the first element of the record is equal to Jay Chou. If it is, I will prune its record 1 and convert it to an integer, which will give me the information of the year 2000. It is important to note that by pruning the record 1, I will obtain the accurate debut time of Jay Chou in the year 2000. In fact, when it comes to this, it is extremely simple. If our file can be read programmatically, then I actually manipulated it. So in that case, we can always use the Python language to write a script to create a corresponding one without needing to build a database. This approach allows for easy manipulation of the file without the added complexity of database development. I have the ability to control it using this script, and then I am able to retrieve these pertinent pieces of information. But in actuality, if we employ this scripting language to write and develop programs, if you try to read these data and obtain the corresponding information, there will actually be a lot of problems. Afterwards, we will delve into these interconnected issues, and ultimately, in conclusion, we will summarize these issues together and devise strategies to effectively solve them. We will construct a database management system, DBMS, to address it, and then tackle these problems within the DBMS. The approach to resolving these problems essentially involves building, in other words, what challenges will these features related to the DBMS encounter? To begin with, how can we ensure that the artist for each album entry remains the same? What if I accidentally misspell it? For instance, if I write Fei Wong as Fei Wan, or Jay Chou as Jay Zhu, or if I incorrectly write the names of Zhao and Fei Wong in this table or file, what steps should I take to rectify the situation? In order to solve this problem, it means that I need to set certain attributes, restrictions, texts, and portability related things in the DBMS if you want it. Another thing is, for instance, if there is an album and multiple artists are involved in the creation process, how do we make a decision? For example, in the 2021 Eason Chan album, the album titled Stranger Under Skin was co-created by both Fei Wong and Eason Chan. So, how can I accurately correspond to and credit both artists for their contribution in this album? Furthermore, it is exceedingly arduous to define the file system in this particular manner. But we use some of this database management system, some of its paradigms, and some table structure designs can bring this 2011 album. I can also say that Eason Chan and Fei Wong jointly created these 2 singers have relevant expressions. What is the definition of a database management system? It is a type of software system. Initially, it is a software system, and then it permits applications to store and analyze data in the database management system. It can be used for storage only, or for storage and analysis at the same time. After the analytical database is expanded, it can also be used solely for analysis, and there is no problem in continuing to do storage and analysis. Supported operations define databases, create new databases, add records, query, update, manage, concurrency control recovery. In case of DB failure, recovery ops are needed. The set of these ops is known as a DB management system. When discussing these products related to databases, we are actually referring to the system responsible for managing databases and ensuring efficient database management. For example, Oracle, SQL Server, MySQL, Neo4j, and CnosDB. All right, let's examine this final page. The lesson for today is relatively simple, or more accurately, it contains more soft aspects. It also serves as a systematic summary for everyone in a comprehensive manner. This DBMS has also developed for 40 years. Initially, it has essentially gone through these 5 stages, and we have also performed a systematic sorting of the data. First of all, from 1980 to 1990, this database management system, it actually appeared the latest among these 3 major systems, later than the compiler and later than the operating system. Compiling is needed for calculations and operations on this data, so designing a programming language and compiling it are early appearances. Then I need to support this operating system after systematizing it. As for the operating system, it also has like some related data. Oh, my files have increased with this computing process and storage process, and I can't manage the files anymore. Then, when my disk's certain related features were not well supported, in reality, it was not until the 1980s that these associated systems of the database started to emerge. The emergence and cleaning of commercial databases can be attributed to the digitization wave in the United States. As technology advanced, large PCs like IBM and Apple's Macintosh-related systems became prevalent. This led to a need for storing documents in sectors such as the military, banks, and medical systems. To address this, a commercial database was developed, categorizing data into a 2-dimensional table model and utilizing circle statements for queries. The rise of American digitization necessitated application-oriented considerations and support. Commercial databases played a crucial role in organizing and managing data, providing a foundation for the development of related systems. This evolution was driven by the abundance of documents and the requirements of the growing digital landscape. Thus, commercial databases became an integral part of the informatization process in the United States. It is Oracle, IBM's DB2, for instance, Sybase, and so forth. Then, as time passes, as time moves forward, following the 1990s, we began to have some AP-type databases. Not only transactional data storage, including this kind of relational database, open source databases like MyCircle, PostgreSQL, and others. The open source community corresponded to relational databases like Teradata, etc. Some related analytical databases, that is, to avoid this read-write conflict, after I separate the writing from the related reading and analysis above, some OLTP and OLAP started to rise in the 1990s, including some new open source databases. Then, starting from 2001 until 2010, certain non-relational databases began to emerge and gain prominence. Particularly internet companies such as Google, every individual will be familiar with certain things like Bigtable, some associated database computing frameworks, and storage systems. In the industry, there is a concept called not only circle, but also no circle. That is to say, in response to these networks that have emerged, like their unstructured, semi-structured documents, and some graph-related ones, a corresponding storage is done. For example, it has more of this no circle with features like MongoDB and Redis. After 2010, from 2010 to 2020, more specifically, it means new circles. By way of illustration, it has been distributed circles, encompassing the so-called disadvantaged storage systems and other column-based such as ClickHouse, Kudu, and other similar technologies and so forth. It actually has more of these native storages. They are not just in relational storage. I can also save pictures, I can also save files, my timeline, my key value, etc., incorporating a larger number of distributed storage properties such as Snowflake, Data Warehouse, and other similar options that are available in the market. This type of data warehouse, the concept of cloud data warehouse, and currently, for instance, HTAP, the combination of online transaction processing, OLTP, and online analytical processing, OLAP, and it supports both transactional and analytical data with its versatile capabilities. Then include more of what was just mentioned, such as Redshift, Snowflake, and other cloud-based data warehouses. One of its cloud-native related features is that there are more vendors, including some big ones like Google and Amazon, participating in the overall database construction. It presents a more diversified development, which is also the corresponding development of database management systems over the past 40 years. Undoubtedly, if I continue, I will provide a more comprehensive explanation of these concepts, including log structure, row storage, column storage, as well as various non-relational databases such as OLAP, OLTP, and other related technologies that are commonly used in data management. Even some classic source code level or data structure level collaborations will be coordinated to engage everyone in deeper level exchanges.